Officer Sarah is riding a motorcycle that can accelerate from 0 to 70 meters per second in 6 seconds. If she starts at rest, how long will it take Sarah to travel 500 meters? All right, let's write down what we know. We know Officer Sarah is going to start out with an initial velocity of 0, and she's going to continue to accelerate until she reaches a velocity of 70 meters per second. Okay? Now she's not going to spend the entire time accelerating. She's going to accelerate until she gets to 70 meters per second. And it's going to take her 6 seconds to do that. So I'm going to draw a little line right here for this first 6-second chunk when she's accelerating. Then she's going to come over here. She's going to continue to travel in this direction at the constant velocity of 70 meters per second. And now our problem is over once she's traveled 500 meters. And then the problem asks, how long will it take her to travel the entire 500 meters? So just like the last problem I did on my YouTube channel, we have to split this problem into 2 parts. We split it into the part where Sarah is accelerating and the part where Sarah is not accelerating, because the acceleration is not constant throughout the entire problem. So I'm just going to leave the second half alone. I'm going to ignore that. I'm going to go over here. I'm going to write down given for the first half of my problem. Okay? Just the first half. So for the first half, we know the first half takes 6 seconds. We know that the initial velocity is 0. We know that Sarah is going to eventually reach a final velocity of 70 meters per second. That is VF for the first part of the problem. And then my battle plan here is I'm thinking, if I can figure out how far she goes while she's accelerating, then I will know how far she goes when she's moving at a constant velocity. This plus this has to equal 500. So if I know how far she goes at a constant velocity, and I know her constant velocity, then I could figure out the time and add it to 6 seconds, and we'll have our total time for the whole trip. So what I'm going to do here is I'm going to find delta x. Okay? So that's going to be my battle plan, and I'm going to use that given to find delta x. So if you go over to your formula sheet, you should find one formula with a delta t, a VO, a VF, and a delta x. The one that's coming to mind for me is the one that comes from the average velocity formula. That would be delta x equals VF plus VO over 2 times delta t. This formula will work because this part of the problem does have a constant acceleration. All right, so now look at that. It's already solved for delta x. We don't even have to do any algebra. I'm just going to plug in my numbers. So VF equals 70. VO is 0. And delta t is 6 seconds. So now we just need to do a little bit of math. This is 70 divided by 2 times 6. 6, if you put that into your calculator, you should get 210 meters. Now, the 210 meters is just the displacement for the first half, for the part where Officer Sarah is accelerating. Now we have to go over here. And so what I'm going to think is, if this whole thing is 500 meters, and she goes 210 meters while she's accelerating, then the rest of this is going to be 290 meters. Just got that by subtracting. 500 minus 210 gets us 290. So now that I have this distance, I can draw, like I did before here, continue this line, draw a line, all that stuff, I use that. I don't need that anymore. What I'm going to do now is I'm going to find the time that she spends traveling at a constant velocity. Okay? So I have my velocity, I have my displacement, I can write down my given. I know that velocity, 70 meters per second. I know that delta x is 290 meters. I'm going to look for delta t. Going to your equation sheet, you should be able to find one equation that has all of that and nothing else. That's going to be our average velocity equation. I can use the average velocity equation because this velocity is constant for this half of the problem. So now I just need to rearrange it. I need to solve for delta t. So I'm going to multiply both sides by delta t. Okay, so we had to get delta t off the bottom of the fraction. Now I'm going to move v over. So I get delta t equals delta x over v. Now I just have to plug in my numbers. So this is going to be 290 divided by 70. And then the time that she spends moving at a constant velocity should be 4.14 seconds. So now I have my delta t for this half. Then a last step, go find some empty space here. We have 6 seconds. We have 4.14 seconds. The problem asks, how long does she spend going 500 meters? That's 6 plus 4.14. So our answer is 10.414 seconds. And that's part 1.